Mmpc005 है ना, अभी बात क्लास में तो बात कर लेना।
Good morning, learners and viewers. Welcome to session for quantitative analysis for managerial applications. Today, we will be discussing about the numerical component, the numerical problems which are related to various topics under this course. Numerical problems comes under measure of central tendency, measure of variation in skewness, continuous probability distributions, sampling distribution, testing of hypothesis, correlation, regression, and chi-square test. I will be starting with a problem which is related to normal distribution. The problem states that the average monthly sales of 5,000 firms are normally distributed with a mean of rupees 36,000 and a standard deviation of rupees 10,000. Now, you are supposed to find the number of firms with sales of over 40,000, the percentage of firms with sales between 38,500 and 41,000. Thirdly, the number of firms with sales between 30,000 and 40,000. Now, since this problem is related to normal distribution, we have to assume X to be a normal variant, which represents the monthly sales of a firm. Now, mathematically, what does this mean symbolically? X belongs to N, 36,000, and 10,000, where 36,000 is the mean and your 10,000 is your standard deviation. Now, going back to the statement of the problem, we are supposed to find the number of firms with sales over 40,000. That means you have to find out the probability of X greater than 40,000. Now, how it is written in normal distribution form. That means you have to convert that into Z variant, where probability, so it will be written as probability Z greater than, mathematically it is X minus mu on sigma. Your X is 40,000, your mean is 36,000, and your standard deviation is 10,000. It comes out to probability Z greater than 0.4. Now, since we have to refer the normal variant table, here we have to find the area under the curve where that is greater than 0.4. That means, as you are aware of, tabular value refers to 0.5 on right side and 0.5 on the left hand side. That means we have to subtract, or we have to convert this p is at greater than 0.4 into the normal tabular form, which means it will be written as 0.5 minus probability 0 is less than equal to Z less than equal to 0.4, because in the tabular form we get the value from 0. That means value of Z variant under the table from the table at 0.4 will be 0.1554. That means we will be subtracting this value from 0.5, which comes out to be 0.3446. Now, their total number of terms are 5. That means we have to multiply this number, the probability what we have calculated, by 5,000. That means we get 1,723. Your answer basically is 1723. That means from a sample of 5,000 firms, 1,723 firms are having sales over 40,000. Now, we have to calculate the percentage of firms with sales between 38,500 and 41,000. Now, what will be the method for writing it? It will be written as P within brackets 38,500 less than equal to X less than equal to 41,000. And you will be converting this into the Z variant form, so it will be 38,500 minus 36,000 divided by 10,000. That is the standard deviation. And for 41,000, for that case, you have to write 41,000 minus 36,000 upon 10,000. After calculation, it comes out as 0.25 is less than equal to Z less than equal to 0.5. We will be converting this into the mathematical relation form, that is probability 0 less than equal to Z less than 0.5 minus probability 0 less than Z less than 0.25. Taking up the value from the normal distribution table, we get the value for 0.5 as 1.1915, and for 0.25 we get 0.0987. After subtracting, we get 0.0987. Since our answer was our question stated that we have to find the percentage. That means we have to multiply this number by 100 to get the answer in percent. The third one was the number of firms with sales between 30,000 and 40,000. Now, we will be following the same method what we followed in the earlier part. That is probability 30,000 less than equal to X less than equal to 40,000. And it will be written as 30,000 minus 36,000 upon 1,000 less than equal to Z less than equal to 40,000 minus 36,000 upon 10,000. We get probability as minus 0.6 less than equal to Z less than equal to 0.4. Now, since we have a negative value, we will be splitting this into two forms, 0 to 0.6 and 0 to 0.4. So we will be writing it in the same manner. Probability 0 less than equal to Z less than equal to 0.6 plus probability 0 less than equal to Z less than equal to 0.4, getting the value for the region under this curve. From the table, as for the value of 0.6 we get 0.2258, and for 0.4 we get 0.1554. Adding up we get 0.3818. Therefore, that required number of term firms between the sales of 30,000 and 40,000 will be multiplying this number, the probability what we have found, by 5,000. We get 1,906. Now, another case related to normal distribution. Using the table of areas under the standard normal curve, find the following probabilities. Now, I will be showing you how this graphically it is shown, how these values are evaluated. So, for your first case is probability 0 less than Z less than 1.3. How we draw it? We normally draw a normal variate curve. Since the area or the probability what we are supposed or what we are asked is from 0 to 1.3, we will be drawing a normal variate curve, and from 0 to any arbitrary value on the right hand side, we will mark 1.3, and this shaded area is basically the probability or the area under the standard normal curve. From the value is 1.3, we will refer to the standard normal curve table. We will get 0.403. That means this part is under evaluation. Second one is probability -1 less than equal to Z less than equal to 0. Since this is symmetrical, then we will be changing up the sign. We can write it as P 0 less than Z less than equal to 1. How it is represented on the standard normal variant curve. Basically, the problem was on the left hand side. which was -1, we will be showing on the left hand side and we will be marking this area. Going back to the table, we will find the value of 1, which comes out to be 0.3413. Third one, we have to find the probability between -1 and 2. -1 is on the left hand side and 2 is on the right hand side. So how to write this in the standard normal linear form? First we will move from -1 to 0 and then we will move from 0 to 2. That means we will be splitting up into two terms. Probability -1 less than equal to z less than equal to 0 plus probability 0 less than equal to 2 less than equal to 2. Then comes conversion from -1 to positive side. That will be because the chart is or the graph is symmetrical, so that the numerical value is not going to change. That means probability 0 less than equal to z less than equal to 1 plus probability 0 less than equal to z less than equal to 2. Referring to the table, we will get the value of 1 as 0.3413 and for 2 we will get 0.4772. We will be adding up and that will be our answer. Fourth one, probability set greater than 1.54. That means from 1.54 on the right hand side. That will be how it will be converted. 0.5 minus probability of 0 less than equal to z less than equal to 1.5. Referring to the table, for the value of 1.54, we will get the value as 0.4382. After subtracting this value from 0.5, we get 0.0618. Now, the fifth problem is probability mod of z greater than 2. That means mod of z means negative side as well as the positive side. Mathematically, it will be written as probability z greater than equal to 2 plus probability z less than -2. Since the value of z is for 2 on the either side, so we can say that this is symmetrical, so we can straight away multiply this value by 2. That means probability, twice of probability of z greater than 2. It will be written as 2 within bracket 0.5 minus probability 0 less than equal to 0 less than equal to z less than equal to 2, because we have the value of 2 from the table. After getting the value of z of 2, that is z at 2, we get 0.4772. After multiplying by 2 and subtracting this value from 1, we get 0.0456. Now, simply there is a change of sign. Earlier it was on the right hand side, now it is between the area between -2 and 2. Simply what we will be doing, this time we won't be subtracting from 1. We will be straight away multiplying, converting it as probability -2 less than equal to z less than equal to 0 plus probability 0 less than z less than 2. Since it is symmetrical, so we will be multiplying it by 2. 2 probability 0 less than equal to z less than equal to 2. Referring to the table, at 2 we get 0.4772. Multiplying it by 2, it will be 0.9544. Now, this is another topic. The two different types of drugs A and B are tried on certain patients for increasing weight. 5 persons were given drug A and 7 persons were given drug B. The increase in weight LBS is given us. This table is given to us. Now, what conclusion we have to know? How the conclusion is drawn? Do the two drugs differ significantly with regard to their effect in increasing weight. And this tabulated value is 0.05 by 2 at 10 degree of freedom is 2.2. Now, the question arises what we have to do. First of all, we will find out the mean of both drug A and drug B. On the left hand side, let drug A part be denoted by x1 and drug 2 part be denoted by x2. We have to calculate the mean. Mean is summation of all terms divided by number of terms. We will be adding up 8, 12, 16, 9, we get 45. 45 divided by 5 is 9. Now, we will be calculating x1 minus x1 bar. That means we will be subtracting the value of x from individually from the mean 9. So that means 8 minus 9 is minus 1, 12 minus 9 is 3, 16 minus 9 is 4, 9 minus 9 is 0, 3 minus 9 is minus 6. Okay. That means third column we will be squaring it. 1, 9, 16, 0, 36. We will be adding it. Now moving on the right hand side. For the drug 2, we will be adding all the values of x2, 10, 8, 12, 15, 6, 8, 11, we get 70. 70 because there are here the number of terms are 7. So we will be dividing this 70 by 7. We get the mean as 10. Now we will be calculating x2 minus x2 bar. Individually, we will be subtracting all these values from 10. We will get column number 2. Then squaring all these values 0, 4, 4, 25, 16, 4, and we will be adding. Now we have each two columns with numbers on each for drug A and drug B. We will be calculating S, that is under root summation of x1 minus x1 bar whole square plus summation x2 minus x2 bar whole square divided by n1 plus n2 minus 2. We have already calculated the value of x1 minus x bar, that is 62, and plus x2, it is 54. And for drug A, there are 5 patients, and drug 2, there are 7 patients. That means N2 will be 7 and N1 will be 5. After calculating this, we get 3.406. Now, our null hypothesis is that there is no difference among the patients when they are administered the drug. And the alternate hypothesis states that it is denoted by H1, which is that there is a significant difference. Mathematically, for null hypothesis, we write H0 is to mu1 is equal to mu2. And for alternate hypothesis, we write H1 is to mu1 is not equal to mu2. We will be doing t-test. T-test, the formula for t-test is x1 bar minus x2 bar whole divided by s square into 1 upon n1 plus 1 upon n2. We have already calculated all the values. Just placing up the values, mean of x1 is 9 and mean of x2 is 10. We have s as 3.406, what we have calculated at the top, and we have n1 as 5 and n2 as 7. After calculating these values, we get C minus 0.501. Now we have to calculate the degree of freedom. For degree of freedom, we have to calculate n1 minus 1 plus n2 minus 1, which comes out to be 10. For the degree of freedom 10, the tabulated value is 2.23. And what we have calculated, the value is less than the tabulated value. Now the conclusion has to be drawn. That means since your calculated value is less than the tabulated value, that means you will be accepting your null hypothesis. Mathematically, it is written as H0 is accepted. Okay? That is, drug A and drug B does not differ significantly with regards to their effect in increasing. But this is the right method of solving a problem. Now we move to another problem which is related to, since the tabulated value of z is given, that means it is a problem related to normal distribution. We assume that the mean height of soldiers to be 68.22 inches with a variance of 10.8 inches. How many soldiers in the regiment of 1000 would you accept to be over 6 feet tall? You are given with the tabulated value of z for the area between 0 and 1.5 as 0.3749. If the tabulated value is given to you in the problem, you don't have to refer to any table. Now, what is given to us? We are having mean height, which is represented by mu, that is 68.22. You are given with variance. Variance is denoted by sigma, which is equal to under root of 10.8, which we are going to get as standard deviation because we need standard deviation. Standard deviation is under root of variance. Now, you have a regiment of 1000 and you are to calculate that you accept the height of soldiers to be over 6 feet. In the graphical relation, you have to show it like this. That means on the right side, that right side represents the area for the probability what we are supposed to get. And we have a value of z. First of all, we have to calculate the value of z. Z is x minus mu upon sigma, or x is 72. 6 feet is 72 inches because your problem, the information of the data what is given to us is in the form of inches. We have to convert this 6 feet into inches. 1 feet is equal to 12 inches. That means 6 feet will be equal to 72 inches. 72 minus 68.22 divided by under root of 10 because we are given with variance and we want standard deviation. This value comes out to be 0.3749. And this is the same value what has been given to us in that problem. Now, refer to the shaded area. Shaded area is on the right side. So we will be subtracting this from 0.4. 0.5 minus 0.3749, which comes out to be 0.125. That means 12.51% of soldiers will be over 72 inches. And that means we have to multiply it. This is in the percentage form. We want the number because our regiment consists of 1000 soldiers. We will be multiplying this value by 1000. We get as approximately 125. That means 125 soldiers will be of the height over 6 feet, or we can say 12.51%. Now we move to a problem of another kind. The average number of customers arrivals per minute at a super bazaar is 2. Find the probability that during one particular minute, exactly 3 customers will arrive. The second part is at the most 2 customers will arrive. And your third part is at least 1 customer will arrive. Here, the average number of customer arrival is given to us. So we can take that as m or lambda. And let the number of arrivals per minute be denoted by a random variable r. Now we have to calculate the probability. In the first case, exactly 3 customers will arrive. That means your r is equal to 3. We will be referring to the exponential part, e raised to the power minus lambda into lambda raised to the power r upon r factorial. That is the basic formula. Replacing the value of lambda or m by 2, we get e raised to the power minus 2 times 2 raised to the power 3 upon 3 factorial. 2 raised to the power 3 is 8, and your 3 factorial is 6. After placing up the values, we get 0.1804. The second case is at most 2 customers will arrive. That means maximum 2. That means no customer, 1 customer, or 2 customers. That means we will be having 3 cases. Mathematically, we can write it as r equal to 0, summation of r equal to 0 to 2 of e raised to the power minus 2 times 2 raised to the power r upon r factor. We can take e raised to the power minus 2 common. First case will be 2 raised to the power 0, second case will be 2, and the third case will be 4 by 2. When we will be adding up, we will get 5. Value of e raised to the power minus 2 is 0.154. After multiplication, it comes out to be 0.6768. The third case is at least 1 customer will arrive. That means minimum of 1, so that means we will be subtracting the value for no customer from 1. 1 minus e raised to the power minus lambda times lambda raised to the power r upon r factor. Our r is 0, anything raised to the power 0 is 1, and 0 factorial is 1. Don't get confused that 0 factorial is 0. 0 factorial is 1, and anything raised to the power 0 is also 1. So we are left with e raised to the power minus 2. After subtracting its value, we get 0.8646. Now, this is a different type of problem. It is related to distribution only. Now, see to the problem. Suppose we know that the weight of cement in filled bags is distributed normally with a standard deviation of 0.2 kg, and we want to know how large a sample should be taken so that the mean high weight of cement in the filled bags can be estimated within plus or minus 0.5 kg of the Q value with a confidence level of 90%. Now here the problem is related to we have to calculate the sample size. Earlier, whatever we solve, we do sample size is normal. Now here, this problem is that we are supposed to calculate a sample size. Here, it is a case of normal distribution because it's written distributed normally. Standard deviation is given to you 0.2, and mean fluctuation from the value is 0.05, and your confidence level is 90%. This information is provided to you in the problem. Now we have to find out the interval. The interval is given by for 90% of the confidence level as x bar plus minus 1.645 times sigma upon under root n. And we are also given with the condition that the mean weight of the cement in a filled bag can be estimated within plus or minus 0.05. So that we want the interval x minus 0.05 to x plus 0.05 with a 90% level of confidence. We will be converting the information into this formula. 1.6454 times sigma upon under root n, which is equal to 0.05. That is the deviation. This all information is given to us. After substituting the value, all the given values, we find that n is equal to 43.3. Either we can take 43 or 44. That means we must have a sample size of at least 44 so that the mean weight of cement in a filled bag can be estimated within plus or minus 0.05 kg of the true value with a 90% of confidence level. Now, this is again a problem related to your probability. The insurance salesman sells policies to five men, all of identical age and good health. According to the actuarial tables, the probability that a man of this particular age will be alive 30 years hence is 2 by 3. Find the probability that 30 years hence at least one man will be alive, and number two, at least three men will be alive. Now here is that what is the information is given to us. After writing the information, then only we can apply which method or which formula we are supposed to. Here, the probability of the event, what we are talking about is a man to be alive 30 years hence. And this will be termed as the probability of success. Here, you are talking a sample size of 5 men, that means your n will be 5. Your p is 2 by 3. And your q will be 1 minus 2 by 3, which is 1 by 3. Now, we have to find out the probability. At least one will be alive. That means for arriving to the probability of at least one will be alive, what we will be doing, we will be subtracting the probability of r equal to 0 from 1. That means 1 minus p r equal to 0. Here, how this pr is equal to 0 is calculated. Refer to the right side. We have a formula of NCR into p raised to the power r times q raised to the power n minus r. In this problem, n is 5. In this particular case, r is 0, your p is 2 by 3, and your q is 1 by 3. Anything, what I told you that anything raised to the power 0 is 1. After evaluating this, we will get as 242 by 243. This is the probability that at least one man will be alive after 30 years. Now, we have to calculate the probability of at least 3. So for at least 3, since we are having 5, so it will be easier for us to calculate PR is equal to 3 plus PR is equal to 4 plus PR is equal to 5. We will be applying this NCR, P raised to the power R, Q raised to the power n minus R only. 5CR, 5C3 times 2 by 3 raised to the power 3 times 1 by 3 raised to the power 2. And similarly, we will be calculating it for R is equal to 0 and R is equal to 5. Keep one thing in mind, anything raised to the power 1 is that number, and anything raised to the power 0 is 1. After calculating, we will get as 64 by 81. Now, another problem which is related to normal distribution. In a normal distribution, 35% of the items are under 45 and 8% are over 64. You are supposed to calculate the mean and standard deviation of the distribution. How to convert the given information into a mathematical relation. First of all, your 31% of the things are under 45. That means P x less than 45 is equal to, it is in percent, so we will be dividing this 31 by 100, which comes out to be 0.31. Now, converting this into your Z variant form. Probability Z less than 45 minus mu upon sigma. Since we are not aware of the value of mu and sigma, we will be just solving this because we are having the probability as 0.31. After converting this, we will get probability 45 minus mu upon sigma less than Z less than equal to 0 as 0.19. Converting this in the form of 0 less than z less than mu minus 45 by sigma, the probability will be 0.19. From the table, we have to get the value of this z variate. Value of z variate will be at for 1 point as for 0.19 will be 0.49. After transforming it, we get mu minus 0.49 sigma is equal to 45. Now we will be referring to the second condition, the probability of 8% are over 64. In that case, probability x greater than 64 is equal to 0.0. Similarly, by the same method, we will be evaluating 64 minus mu upon sigma equal to 1.4. After transforming this, we will get two equations which will be in the form of two variables. Variables will be mu and sigma, and the first equation is mu minus 0.49 sigma equal to 45, and your second equation is mu plus 1.4 sigma is equal to 60. Since we have two equations and two variables, so by the basic method of elimination, we can calculate the value of mu and sigma. After solving it, we will get the values of mu equal to 50 and sigma equal to 10. That was what was asked in the problem. Now we move to base theory. Our car manufacturing factory has two plants, X and Y. Plant X manufactures 70% of the car. Plant Y manufactures 30% of the car. 80% of the cars are at plant X, and 90% of the cars at plant Y are rated of standard quality. That means probability of quality cars from the respective plant is given to us. A car is chosen at random and is found to be a standard car. What is the probability that it came from plant X? We have two plants, X and Y. We can, since the event is of selecting a standard car, so we can say that there are two plants, X and Y. We will be in this problem referring their probability by B1 and B2. That means probability of B1 is 70% of the production. 70% means 70 upon 100, which comes out to 7 by 10. And for second plant, plant Y, probability B2 is equal to 30 by 100. That is 3 by 10. For the simplicity of solving the problem, try to keep the denominator of all the probabilities and all the values the same. That is why we will, here in this case, we will keep it as 10. Now, a car is selected from a plant, respective plant, and it is said to be of standard quality. For selecting a standard quality car from plant 1, so mathematically it will be denoted as P E by B1, which is 80%. 80% means 80 upon 100, which comes out to be 8 by 10. And for the second plant, 90% of the cars of the plant Y. In that case, we will be writing probability E by B2. 90 by 100, that is 9 by 10. Now, what we are supposed to calculate? We have to calculate the value of the probability that a standard car came from plant X. How it is written mathematically. Probability E1 by E. That means the probability that a standard quality car has come from plant X. Now, how it is written mathematically. P B1 into P E by B1 upon P B1 times P E by B1 plus probability B2 into probability E by P2. Now, to make things simple and easier, you can see that in the numerator, you will get denominator as 100, and in the denominator part of the denominator will also be 100. That means to make it simple and easy, what we will be doing, 7 into 8, 56. Correct? 7 into 8 for the denominator is again 56 plus 27. 56 plus 27 is 83. There is no need of making things difficult further or making error in calculation. You can see it. The denominator of the numerator is 100 and the denominator of the denominator is again 100. We can remove it. 7 into 8 is 56, and for the denominator part, its numerator will be 56 plus 27, which is 83. Now I am moving to another part of this question. Now here you are supposed to find the probability that a standard quality car came from plant Y. What will be the difference in the solution of this problem? Numerator will be replaced by 3 by 10 into 9 by 10, and your denominator will remain the same. That means we can say that our answer will be 27 by 83. You can do it. Now we move to problems related to sampling distribution. The average monthly electricity consumption for a sample of 100 families is 1250. Assuming the standard deviation of electric consumption of all families is 150 units. Construct a 95% confidence interval estimate of the actual mean electric consumption. Now the thing is that first of all, we have to convert the given information in our mathematical form. We are talking about 100 families. That means n will be 100. Your monthly consumption is given. It is mean. X bar will be 1250 divided by 100, which comes out to be 12.50. Your standard deviation is given to you as 150. And you are being asked to calculate or to construct a 95% confidence level. That means the confidence level is 1 minus alpha equal to 95%. For 95% of confidence level, the confidence coefficient will be 1.96. Since you are given with mean and standard deviation, we will be referring to standard normal curve. Now how to convert this? The confidence level with alpha by 2 is equal to 1.96 for 95% confidence level, which is given as x bar minus z alpha by 2 times sigma upon under root will be less than equal to mu less than equal to x plus z alpha plus alpha by 2 sigma upon under root n. Refer to my earlier problem, I used that value 1.6945. That was 90%. Here it is 95%. Your mu plus minus 1.96 times 150 upon 100, under root of 100, which comes up to be 1250 plus minus 29.40. That means at 95% level of confidence, the population mean is likely to fall between 1220.60 units and 1279.40 units. That means we can write it as 1220.60 less than equal to mu less than equal to 1279.40. Now we move to a problem related to testing of hypothesis. We have already done earlier in today's session, I'm exposing you to another form of the law. A typist claims that he can type at a rate of 120 words per minute. Can we reject his claim on the basis of 100 trials in which he demonstrates a mean of 116 words and standard deviation of 15 words? And we have to use 5% level of significance. Here, again, the same thing is that standard deviation is given to us, mean is given to us, and n is given to us. First of all, how to convert this, how to solve this problem? Yes, basic question is, can we reject his claim that on the basis of 100 trials in which he demonstrates a mean of 116 words with a standard deviation of 15 words? First of all, typist claims that he can type at a rate of 120. After taking a trial of 100 trials, we found that the mean was shifted to 116 words with a standard deviation of 15 words. Mathematically, how we will write for hypothesis setting? Null hypothesis, we claim that the typist claim is true. That means h naught is to mu is equal to 120. And the alternate hypothesis will be h1, that is h naught is to mu is not equal to 120. This is a case of two-tailed test. Test statistics, what we are having. N is equal to 100, it's given in the problem. X bar is 116 for the problem. Mu, it means mean is 120 words, and your S is 50. We have a relation for standard mean error, that is standard error mean is equal to sigma upon under root n, which comes out to be 1.5. Now we have to calculate it, the Z statistics. Z is equal to x bar minus m upon s times s upon under root n. After getting all these values of 116 minus 120 upon 1.5, we get a value of 2.67. The level of significance is 5%, that is 0.05. Critical value of Z alpha at 5% level is 1.96 from the tables. What is the conclusion? We get a value of 2.67. As the value of mod 2.67 is greater than 1.96, the null hypothesis is rejected. And the conclusion is that the claim made by the typist that he can type at the rate of 120 minutes per minute is incorrect. Similarly, a same problem, but here the information is different and the conclusion may be different. The mean lifetime of a sample of 400 bulbs produced by a company is found to be 1570 hours with a standard deviation of 150 hours. We have to test the hypothesis that the mean life of the bulb produced by the company is 1600 hours against the alternate hypothesis that it is greater than 1600 hours at 1% level of significance. Here n is 400, which is too large. X bar is 1570. Your standard deviation is 150 hours and mu is 1600 hours. You will be setting up the hypothesis as h naught is the mean life of the bulb is 1600. So that means h naught is to mu is equal to 1600. And the alternate hypothesis will be h1 is to mu greater than 1600. So what we are supposed to calculate, it is a right tail test where mu is greater than 1600 hours. First of all, we have to calculate the standard error, that is sigma upon under root n, which comes out to be 7.5. For Z statistics, x bar minus mu upon s under root n, we get as negative 4. Taking more value as 4, we will be eliminating negative sign. The level of significance is 0.01. Mathematically, from the table at 1% level of significance, Z alpha is 2.33. Here, our calculated value is 4 and the tabular value is 2.33. Here, the null hypothesis is rejected and the alternate hypothesis is correct. That is, the mean life of bulb is greater than 1600 hours. Now, this is a problem which is related to testing of hypothesis about a population portion. In a sample of 100 people in Mumbai, 540 are rice eaters and the rest are wheat eaters. Can we assume that both rice and wheat are equally popular in this state at 1% level of significance? Here n is 1000 and x is 5. So sample proportion will be x by n, that is 540 by 1000, which comes out to be 0.5. Population portion not given, so we select as half. A is equal to 1 by 2 and q is equal to 1 by 2. For null hypothesis, we can state that h naught is to p is equal to 0.5 and the alternate hypothesis will be h1 is to p not equal to 0.5. We are having small p equal to 0.54, n as 1000, probability as 0.5 and probability of failure as 0.5. Putting up for the test statistics, z is equal to p minus p upon under root pq by n. We have all the values given in the problem. So after substituting the values, we get at 2.52. Your calculated value is z is equal to 2.529 and your tabular value is greater than your calculated value. Tabular value is 2.58 and you have calculated as 2.52. That means h naught is accepted. Another problem, a machine puts out 16 imperfect articles in a sample of 500. After the machine is overhauled, it puts out 3 imperfect articles in a batch of 100. Has the machine improved? This may be assumed to be, can be said to be a practical problem. Here what is given to us? N1 equal to 500, X1 equal to 16, N2 equal to 100, and X2 equal to 3. Before servicing, it was 16 by 500, which was 0.032. If we are taking it as before servicing, the probability is P1, its failure Q1 will be 1 minus 0.03, which comes out to be 0.968. And after service, we are taking it, the probability is P2, which comes out to be 0.032. That means Q2 will be 0.968. For testing up the hypothesis, we assume that the machine has not improved. If the machine has improved, then P1 will be greater than P2. Here, population proportion proportion is not. What will we be doing? We have to first of all calculate that P. It is calculated as N1 P1 plus N2 P2 upon N1 plus N2. We have all the values with us. After substituting this value, we get capital P as 0.03167 and your Q will be subtracting this value from 1, which comes out to be 0.96. Now we will be testing on the statistics at Z, which is P1 minus P2 upon PQ times 1 upon N1 plus 1 upon N2. After substituting all the values, what we get? We get Z equal to 0.1037, which is less than the tabular value. And your tabular value at 5% level is 1.61 and you have calculated 0.1037, which is less than. Therefore, yes, we conclude that the H naught is accepted. A sample of 100 students is taken from a large population. The mean height of these students is 64 and standard deviation is 4. Can it be reasonably regarded that the population mean height is 66 inches? Value at the value of z at 5% is 1.96. Straight away, you will be assuming that mean height is 66 inches. And alternate, which is not. That means it is a two-tailed test. If first of all, we will be evaluating that statistics that is equal to x bar minus mu upon sigma upon under root. We get as minus 5. At 5% level, we have a value of 1.96. Since the calculated value lies outside the acceptable region, we will be rejecting expert. That means the population height cannot be 66 inches. Here, this problem is related to the probability, basic probability. The overall percentage of failure in a certain examination is 40%. What is the probability that out of a group of 6 candidates, at least 4 passed? Probability of failure is given to us. That is 4 by 10 or 2 by 5. That means probability of success will be 1 minus 2 by 5, which comes out to be 3 by 5. We are supposed to, and here n is 6 because we are taking a group of 6 candidates. Now, we have to calculate the probability of at least 4 pass the exam. That means 4 has passed the exam, 5 have passed the exam, and 6 have passed the exam. We will be adding all these individual probabilities of 4 passing the exam, 5 passing the exam, and 6 passing the exam. The probability will be solved by NCR, p raised to the power n minus r times q raised to the power r, where your NCR is n factorial upon n minus r factorial times r factorial. Remember, 0 factorial is 1. Anything raised to the power 0 is also 1. After calculating all these values, you will get 1701 upon 3125 as the solution. Now, we have the problem related to calculating the Wallis coefficient of skewness and Karl Pearson coefficient of skewness. For the given, this data is given to us: monthly sales, monthly wages, and number of employees. First of all, we have to remember the formula for coefficient of skewness and the formula for Karl Pearson coefficient of skewness. This is the table what has to be generated for calculating these two coefficients. Monthly sales and number of employees were given to us. We have to first of all calculate mean, because number of frequency and the monthly wages are too large. First of all, we have to find the mid values. Mid value is 600 plus 700 divided by 2, which comes out to be 650. We will be adding 100 till the last one. So that means this column will be 550, 650, 750, 850, 950, and 1050. Now we have to calculate deviation. T is equal to x minus a upon I. Now the question arises, what is a? At the middle of this mid-value column, we can assume any value. So here in this problem, we have assumed 750. So we will be replacing in the column of D is equal to x minus a by I. The simplest method is the row in which you have assumed straight away write 0 and over it write -1, -2 and below it write 1, 2, 3. You have to calculate d square, fd square, fd and cumulative frequency. After getting all these values, you have to sum up except for the cumulative frequency. Mean is a plus summation fd square upon n into y. Substituting the values, you will get 766.6. Secondly, we have to calculate standard deviation. That is summation under root of summation fd square by n minus summation fd by n whole square into y. Substitute of the values, you will get as 124.8. Then calculate median. Median is basically for Karl Pearson coefficient. Median is L is equal to 700, n by 2 is equal to 60. Cumulative frequency is 35, I is 100, and the frequency of the model class is 45. Your median will be 755.66. With this, we will be concluding today's session. Oh yeah.